A little bit about comets. And I'm fiddling with this bag and not really explaining what I'm doing because I'm modelling what I'm doing to the students. You haven't got a clue, unless you've seen this before, you haven't got a clue what I'm doing, nor have the students. But that's okay, a bit of surprise. I'm talking about comets. Does anybody know about the Rosetta mission? You can start asking students about this. So have a quick look, quick refresh about the Rosetta. Rosetta mission, space mission, a 10-year mission, great physics. We could build the probe on board, the Philae lander. I know some of the space, some of the scientists on there. It took at least 10 years planning. It took 10 years journey. It's 20 years old. You made little jokes about the computer technology on it. It's 15 years old at least. And the idea is that once it got to Rosetta, because anybody could remember the passwords. I mean, it's using Windows. What's 15 years? It's like using Windows 1. But get the kids thinking about. It's 15 years old. If people think it's really modern, it's not. But it still worked-ish. But it took, Rosetta went 3 times around the Earth, slingshot. You can introduce the idea of gravity. We haven't even touched on gravity, which is one thing we were meant to do. We haven't going to do that because you introduced that idea of gravity to get this mission. But anyway, we've got to Rosetta and we've put this little Philae lander on it. Do we know what happened? It bounced. And this is a little model to show you why. But we know the chemicals on the model. So we could use this, use a spectrometer. You can introduce Raman spectroscopy, it's probably not on the A-level spec, but molecular spectroscopy or some sort of spectrometry, which is on the A-level spec, you could use it because those extra instruments on the Philae did. And what did it detect? It detected lots of water. Again, you're really not sure what I'm doing. I'm just chucking water in a bowl. Okay, don't tell them. Now, we don't know where the Earth's water came from. We do know that the Earth was hit under what's called the late bombardment with lots of comets. And we now know comets have got water on. So therefore, the Earth's water came from comets. Not quite. Because when we've analysed the water, the isotope ratio of the heavy water is slightly different from some comets to what's on Earth. And we think there's a difference between short period and long period comets. I'm not going to talk to you about Kuiper belt and the Oort cloud, but there's loads of physics there for you. So Earth's water could come from comets, but it's not as simple. One reason why we went to land on a comet is the rocks. Because the rock in a comet is the oldest rock. These are the building blocks of the Earth's solar system. Any rocks we have on the Earth would have gone through sort of volcanic processes, erosion, but in a comet, the earliest building blocks would have drifted out to the outer reaches of the solar system, and so that was the original material, and that's why we went. So all I've got here is some sand and grit. It's basically sort of sand, grit, salt that our guys put on the path when it's freezing. I just use that. And of course, you've perhaps got your really naughty lad who can't. Sorry, that was so sexist. It could have been a really naughty girl, couldn't it? Your really naughty boy or girl who won't sit still. You've got them at the front with the goggles on, and they've got their lab coat on, and they're doing the stirring because they'd love that and keep them out of mischief, stuff like that. Give them a job to do. So a comet has also got an awful lot of carbon in it. It's got a lot of carbon compounds, and I'm modelling this with graphite. So I've just got some powdered graphite. I just chuck in here. Again, you don't know where I'm going with this, but it doesn't matter. You're entertaining the students with your science. Why is this really important to us? Well, some students are going to say, well, aren't we carbon-based? A teacher would have said that we're carbon life forms. Yeah. What's that got to do with anything? We've also found alcohols, methanol, ethanol, and complex alcohols on a comet. How do alcohols formed on the Earth? Well, process of fermentation. One of your students will tell you that. That can't be what happens in space, but there are other chemical processes. We found alcohols, and I'm modelling this with a very quality screw top red from Astra. It's about 99p a bottle. That's a quality,
very
quality brew there, and he's stirring it up. Right, I've got 2 ingredients now. I need a student to go and fetch it for me. Can I go? Right, okay. Will you go and get us a pint of horseweed, please? Horseweed's got a lot of ammonia in it, and I've found a lot of ammonia on comets. So but I don't want to do it because it stinks. Right, could you go and get us some rotten eggs? Rotten eggs give off the gas hydrogen sulfide, which stinks. Again, that's found on comets. All right. So those two things are in. We don't put them in because they stink, but comets stink. And comets have an awful lot of Worcester sauce. The Worcester sauce is the model, because what makes Worcester sauce tart are the amino acids. And we found on a comet a lot of the amino acids. Now, astrobiologists, and yes, there is such a job, astrobiologists get really excited about this. Water, silicates, alcohols, carbon, amino acids, build up to get proteins. There is a theory that is the ingredients of life. Give that, put it in a warm, muddy with some lightning bolts so there's lots of energy, give it 1 billion years and something might start crawling out of that. Life could evolve. They're the components of life. That's not the primordial soup, but many people say that the contents of the primordial soup is brought to Earth by comets. And that is a theory. Right. The other thing that comets have a lot of is carbon dioxide, but it's very, very cold. So I need to go and get some very, very cold carbon dioxide. And it's my secret safety over here. You have to have thermal mitts on. It's dry ice. It's at minus 78 degrees C. It must, and we'll talk about the safety of this, but you've got to be careful with it. And whatever you do, don't carry this and then trip and pour it down the student's neck. I'm being serious. That's minus 78 degrees C is instant frostbite. Yeah. If you can find, and wherever you're teaching, and you're teaching post, I know it's not the most important thing for you, but if you can find somebody who can provide dry ice for you, there's so much you can do with it. We get this, if you're near Leicester, we get it from a company. They will deliver, but it's a bit expensive. I go and pick it up. Find somewhere that will do it for you. You can make it yourself. But it's so difficult. You know, we buy this in kilograms. It's fantastic stuff. Did you want to just step back a bit, because it just lean back because it spits a bit. And students love that. And because you can get your students, you can't put your hands in there, but you can come and pick up a cloud. You can hold a cloud. People say you can smell the Worcester sauce and the alcohol.
Yes.
Yeah.
Yep.
Quite nice.
And you can hear it. Just doing that is fantastic, and you can hear it boiling away. It's boiling cold. And then that's what actually is boiling. You know, what does boiling mean? And there's so much physics here you can do. It's just boiling doesn't have to be hot. It's just the relative temperatures. And so I haven't done anything really, have I? I haven't told you what I'm doing, but I've put together all the ingredients for something that's in a comet. And if I can get it out, and then you try and hide it like this, because you want to do the great reveal, you've actually made a comet. And that hissing, fizzing, dirty snowball, that's what it's called, it's a dirty snowball theory, is a comet. And your students can start perhaps thinking, well, I can understand now how comets have a tail. You can see the outgassing of carbon dioxide. Comets are some of the darkest things in the solar system. They're incredibly difficult to detect until they get near to the sun. Why? Because they are black. And don't forget, this is freezing cold. It's cold on my hands now. It stinks of horsewee, rotten eggs. It's freezing cold, and the poor little feline lander is just down there all on its own, tucked away in the dark. You know, this sort of stuff like that. But it does actually teach us something, because I'm aware of the time. Because of this. The feline lander was designed that when it landed, the system was like a car crash. That if you, I say, let's hope you don't, but in a car crash, the sudden impact will release the airbags. So the idea is the sudden impact of a hard collision was going to release harpoons that harpooned into the surface that fixed the Philae lander to the surface. But it's soft. It's softer than we thought. So when it landed, it wasn't a hard impact, it was a soft impact. The gravitational field is a lot less than we thought. It isn't a hard surface, so it didn't release the harpoons and it bounced back up. About half a kilometre, then bounced back down, and we think it may have bounced twice, and then it did land and did start emitting data until its batteries ran out. But that explains to the students that little story of why, because we don't know why we don't know why it's not as hard as it should be, but that explains. Now while that's got settled down, you mustn't let the students have it when it's, but with the mitts on, if they were wearing goggles, I'd let my older students hold that, and many of them sort of got a little picture of myself with my Comet, stuff like that. I'd let the students do that. There's loads and loads of notes to go through this. Before we move,